Children, here the question is, if two chords of a circle intersect within the circle, means two chords are there and they are intersecting inside the circle. So AB and CD are two chords and they are intersecting at point Q. P is the center. We all know that line segment is a part of a line. So here segment means a part. So in chord AB, there are two segments, AQ and QB. AQ is a bigger one and QB is a smaller segment. In chord CD, CQ is the bigger segment and QD is the smaller segment. So we have to prove the bigger segment of both the chords are equal, like AQ equal to CQ, and smaller segment of both the chords DQ equals to QB or BQ. Now we will draw perpendicular from center to the chord. It's a theorem that the distance from the center to the chord is always perpendicular. And also it bisects the chord into equal part. Means it bisects the chord. Now we are going to join PQ, means center and the intersecting point of both the chords. Let's label it as R and S. Now this triangle, there are two triangles here, PRQ and PSQ, and we are going to prove that they are congruent. So we know angle PRQ equals angle PSQ equals 90 degree. Now this side PQ is common, which is the hypotenuse for both the triangles. So hypotenuse is equal and one angle is 90 degree and PR equals to PS because perpendicular distance is equal if two chords are of equal distance. So by RHS property, congruence criteria, these two triangles are congruent. Triangle PRQ and triangle PSQ are congruent. Hence by CBSE, this RQ equals SQ. And we label it as equation 1. As AB equals CD, it is given, we label it as equation number 2. Now, if we divide by 2 or multiply by half both the side, it will be half AB and half CD. And half AB is either AR or BR. So we will write AR, and half of CD is either SC or DS. So we will write SC. Now this will be equation 3. If we will add equation 1 and equation 3, so both the left hand side and right hand side will be added. So left hand side is RQ plus AR and right hand side is SQ plus SC. So RQ plus AR will be RQ plus AR is AQ and SQ plus SC is CQ. So these are the bigger segment of each chord, and we have proved that bigger segment of one chord is equal to the bigger segment of another chord. Now for minor segment or the smaller segment like DQ and BQ, if we subtract 4 from 2, and second equation is AB. So left hand side of both the equation will be subtracted. So AB minus AQ equals CD minus CQ. Now AB minus AQ is BQ and CD minus CQ is DQ. So minor segment or the smaller segments are also equal. These two we have to prove. Hence, it's proved. Children, stay connected with me, Maths with Kiran ma'am, for more updates. And I'll solve each and every questions of this exercise. Thank you.